Hello physics students! In this video I want to take you through some of the basics that we're going to be focusing on in our unit with the pendulum. This is our unit 1. We're going to be talking about building relationships using data. And the core skill that I want to talk about in this video is doing something called linearization. And I'm going to talk through a couple of the steps, show you an example with some data, and then also connect this to what you're going to be doing with your pendulum data in Unit 1. So for the first thing we want to talk about is what is the goal here? What are we trying to do when we talk about linearizing? And often in science, you're going to be faced with some data, you graph that data, and you want to figure out what kind of equation best relates this because I want to use that to make predictions or make assumptions and develop some models. And so what we're going to take a look at are some basic graph types that fit a lot of our situations that we'll be taking data about. Our first one is the obvious one, is the linear graph where the relationship is proportional. So y is proportional to x. As x increases at a certain rate, y increases at the same rate. And we have an equation that we can use, the y equals mx plus b, to easily describe that. We know that the slope of the line is the m, and then the y is the y value, and the x is the x value, and the b is the intercept of the y on that. So we're going to use that type of equation to help us make an equation based on data that we're collecting from our experiments. Now the first unit is a very simple experiment that I'm going to have you do with a pendulum. And we're going to take some data, and then you're going to build your relationship using these techniques. So there are other relationships, of course. You might have an exponential relationship. So as y is proportional to the x values to some power, like maybe they're squared or cubed or to the fourth power, things like that. And that's going to take this general shape here where you kind of see it curves up. Then you might also have an inverse relationship where the y values are proportional to 1 over x. So as x increases, the y values decrease. And similarly, there might be an inverse squared relationship. So as the x increases, the y decreases more drastically. So those inverse relationships are often present in our mathematical modeling of physical things. And then the last thing is a square root relationship. So if we take a look at this and we talk about y being proportional to the square root of x. So as the x values increase, the y values do increase for a little bit, but then they taper off the rate that they're increasing. So they're still increasing, but they're not increasing as much. All right, so with these 5 basic types of relationships, we can in physics describe most of the things that happen in our physical world. We just need to discover what relationship best matches the data that you are collecting in your experiments. So that's the next thing that we're going to take a look at. So here are the basic steps, and the goal is always to discover a y equals mx plus b relationship. Okay, so I put that right here at the top. This is our big goal. We're going to try to fit any of our data into that linear relationship. Therefore, it's called linearizing the data. So the first thing you're going to want to do is graph your data. Then we're going to look above to see which type it best matches. So which of those 5 best is the match. We'll adjust either a y or an x value that we think is the best match. So if it's a power relationship like x squared, we're going to take all of our x values and we're going to square all of them. And so then we know that the y is proportional to x squared. If it comes out linear, so when we regraph it, if it becomes out linear and it matches a linear line, the best fit is the linear line, then we know that that is our relationship that we can use. We rewrite the y equals mx plus b, and therefore we have our equation. All right, so let's get started. I want to show you some sample data. We're going to first talk about something that's totally linear because I want to show you how to do this in a spreadsheet without manipulating a lot of the values. So I look at this, I prefer using Excel. You can use it either on your iPad, and if you do that, I'll put some instructions in the course about how to sign in with our Minnetonka account so that you can access the full version of Excel on your iPad. The other option is to just use Excel on a computer, and again, I'll link some of those instructions on how to do that. Other graphing tools also work. What won't work is Google Sheets on your iPad. So you have to use a different graphing tool. I'll list them in the course, but the basic idea is finding a spreadsheet tool that can do trend lines. That's what we need to find. All right, so once you put your data in there, and I just did this made up data, I have on the y-axis, I have force, and on the x-axis, I have acceleration. So I'm trying to determine how are these two things connected. Once I graph that right away, it looks like a straight line. I can confirm if it's a straight line by adding a trend line. So in Excel, there are different elements that you can add to your graph. So after you've made your graph, they call them charts in Excel. After you've made your chart, you can go to the top menu, and right here, it allows you to add elements. The element that you want to pick is the linear fit. Then it won't show you the equation on the line right away until you do the second part, where you actually have to go into the layout area and then pick the layout that has a graph example in it. I'm sorry, not a graph example, a equation example. That then will put the equation on your graph, and then you can see how linear it is. Now in this case, we're very linear. Our square value, when I did the trend line, was 1. That's as linear as you can get. So if that comes out to be close to 1, you know you're on the right track. The last step is to rewrite your equation in the y equals mx plus b form, knowing what y and what x represented in our data collection. Okay, so our equation from the graph was y equals 6x. Okay, I need to go back and figure out what does y stand for and what does x stand for based on the data that I was collecting. So when I look back on my data table, and I can do that right here, this would be my x value. So acceleration is x, and then force is my y value. Okay, so I'm going to go back then and put that into my equation. Y gets replaced with force and times 6x. Force then is equal to the slope of the line, 6, times what x stands for. Well, an x is our acceleration. So here's my y equals mx plus b equation. There is no intercept, so it's just f equals 6 times a. Notice the slope of the line, the m was constant, and in this case it might represent a constant value that we in our experiment, like in this case maybe mass. So here's our formula, f equals ma, just derived from some data that we may have collected in our lab. All right, so that's kind of the big idea of what we're doing with our equations and how we're linearizing them. What you need to do in yours is look at your data from the pendulum experiments that you're taking. You might do this in person. You might have a pendulum that you use, even a cord for your iPad. If you just use the power cord, dangle it off the edge of the table, you have a pendulum. You can measure the period and measure the length with a ruler. Or if you want to use one of the simulations, that works out great too. Either way you do it, you need to collect data of length and or whatever variable that you're choosing that might affect the period and the period. Now, I made up complete data here. This is not something that you should use. This is not accurate to any pendulum experiment whatsoever. It's just data to show you the relationships that we're looking at. So once I collect my data, I'm going to put it into my Excel document or graphing tool for my spreadsheet, and I'm going to make a chart. I'm going to make a graph of that data. The next step is to look at the shape of my graph. Okay, now I'm going to look at this and it looks generally linear. Like I could maybe connect a straight line kind of in this general pattern, and I might have a linear relationship. So I'm going to try that. I'm going to go to my trend line, and just like before, I'm going to add an equation and I'm going to look for a linear match. This R value is not very strong though. And it doesn't make sense really to have my intercept be at this point, because if my length is 0, that would mean my period is about 5. And that just physically doesn't make sense. So there might be a better match. In fact, I might look to a trend that looks like this instead. And that would be more of that square root relationship. So in this case, my y values might be proportional to the square root of x. Okay, so what did y stand for? In my graph, y was the period, x was the length. So I'm looking for a relationship between the length and the period of my data. I'm going to then linearize this by adjusting my x values, because I'm predicting my x values are a square root. So what I'm going to do is I'm actually going to change my x values in my spreadsheet and regraph them. All right, so what I'm doing here, because I think it might be a square root relationship, I am telling the spreadsheet to take whatever values it has in x and actually take the square root of them, and then I'm going to regraph that with my old y values, okay? So how do I do that in a spreadsheet effectively? Well, you can use formulas, and if you haven't used formulas before, this is pretty easy to do. Set equal in your cell, and then tell the cell what to do. A38 is the data from A, column A, and row 38. So in this case, it's taking that X data, and it's going to take the square root of it. This is computer language for the square root to the power of a half is the same thing as a square root. And then I can fill down into the other cells. I've already done that here, so those values are already added in. I'm going to then regraph that new X value, so the new length to the square root, times the old y value, or sorry, not graph with the old y value. Okay, I'm not multiplying them, that'd be crazy. Now I'm going to re-look at my line. Is it linear? And if so, I have found the y equals mx plus b relationship I'm looking for. And in this case, it sure is. It's very linear. So then I'm going to use this equation. So I'm going to display my equation again after I apply the trend line, changing the style so I can see the equation. And I'm going to use this as my slope. 6.54 is the slope for that line. And look, the y-intercept is pretty much negligible, so I can ignore that. I'm going to go back to what my equation looks like. Y equals mx plus b form. I know the y is really the period. The slope I got from the equation off the graph. X is really x to the half power, or the square root of x. So I have to put that into my final equation. And then I can write it as this. Period is equal to the slope, 6.54, times the square root of length. I do that because the length is what we're measuring with x. So here's the basic breakdown. I want you guys to do this with your data that you get from your pendulum, because your job is to find an equation using this method for your data. It's not something you can look up on the internet or find in a book. I need you to use the data that you collect from your experiment in order to find out your specific relationship for your pendulum. And then you can use that to make a prediction and match that to one of the future assignments. Thank you guys. Please reach out if you have any questions, and have a great day.